Today we will be modeling and solving equations using algebra tiles. What are algebra tiles? Algebra tiles are an amazing tool that helps us visualize algebraic expressions and equations. We use different tiles to represent the different components of our equation, constants and variables. We represent constants with the unit tile. Each tile represents one unit. If a unit tile is yellow, it represents +1. And if it is red, it represents -1. If we want to model the number 3, we use 3 yellow positive unit tiles. What number would this represent? 6 red unit tiles would represent -6. Let's look at variables. To represent variables, we use an x variable tile. One tile represents 1x, also written as just x. Positive variable tiles are green, and again, negative tiles are red. What expression is modeled by these tiles? We have 2 red variable tiles. That represents -2x. Let's put our tiles together. What do you think this represents? We have 5 green variable tiles, which represent 5x, and 2 yellow unit tiles, which represent the number 2. So we have 5x plus 2. Now we're going to use algebra tiles to model and solve equations. Before we get started, let's remember some principles of solving equations. First, whatever you do to one side of the equation, you have to do to the other. We can't take tiles from one side without taking them from the other as well. This is how the equation stays balanced. Second, to solve an equation means to isolate a variable. The beauty of these algebra tiles is that they help us see the math. When we have one variable tile by itself, we've solved the equation. Now that we know how to use our tiles and we know how to solve equations, let's put it all together. In our first example, we have the equation 3x equals -18. We want to model this equation with tiles and then solve. To represent an equation in tiles, we have to set up both sides of the equal sign separately. On the left-hand side, we have 3x, so we need 3 positive variable tiles. Those are the green rectangles. Let's put those on the left side of our equal sign. On the right-hand side, we need -18. So we need 18 negative unit tiles. Those are the small red squares. We put those on the right side. And now we've modeled our equation 3x equals -18. Let's solve this equation. We have 3 x's, but we only want 1. We can't simply take 2 away because there aren't any variables on the right-hand side to remove and keep balance. Let's think this through. If 3 x's are equal to -18 unit tiles, how many unit tiles is equal to only 1x? If we divide both sides of our model into 3 groups, we can figure this out. Each variable tile is equal to a group of -6 unit tiles, so x must equal -6. That's our answer. How would we have solved this algebraically, or without tiles? Think about inverse operations. 3 times x is multiplication, so the inverse operation is division. We would divide both sides of the equation by 3. And what did we just do? We literally divided our tiles into 3 groups. This is how we can use the tiles to visually see the steps of solving equations. Let's look at another example. In example 2, we have the equation 2x plus 9 equals 15. Let's model this equation with tiles. What tiles do we need on the left side of the equal sign? We have 2x and +9. So that's 2 green x variable tiles and 9 yellow unit tiles. What about the right side? We need 15 yellow unit tiles. Now that we've modeled the equation, we can solve. We need to get 1x by itself. Let's start by getting rid of these 9 unit tiles on the left. If we remove a tile from the left side of the equal sign, we also have to remove one from the right. Remember, whatever we do to the left, we also do to the right. And we keep doing this until we've removed all 9 tiles on the left side. What's left? We have 2x equals 6. For our last step, we need to divide our tiles into 2 equal groups so that we know the value of 1x. Each group has 3 unit tiles, so x equals 3. We've solved our equation. Let's walk through this process algebraically. First, we removed 9 unit tiles from both sides of the equation. That means we subtracted 9 from both sides of the equation to get 2x equals 6. Secondly, we divided the tiles into 2 groups. Algebraically, that means we divided both sides by 2 to get x equals 3. Let's look at a slightly more complicated example. In this example, we have the equation negative 2x minus 2 equals negative 10. What does this equation look like modeled in tiles? On the left, we have 2 negative x variable tiles and 2 negative unit tiles. On the right, we have 10 negative unit tiles. There's our model. Now let's solve. First, we need to get these variable tiles alone. That means we need to remove the 2 negative unit tiles. Don't forget, whatever we remove from the left, we also remove from the right. Notice, algebraically, we are subtracting negative 2. A simpler way to write that is adding 2, since subtracting a negative is the same as adding a positive. This leaves us with negative 2x equals negative 8. Now we want to divide our tiles into 2 groups. Each group has 1 red variable tile and 4 negative unit tiles. So negative x, or the opposite of x, is negative 4. But we want x, not the opposite of x. So if the opposite of x equals negative 4, then x equals 4. Algebraically, we generally put these 2 steps together. Rather than divide by 2 and find the opposite, we simply divide by negative 2. Negative 8 divided by negative 2 gives us positive 4. Let's look at one last example. Now we have the equation 3x minus 8 equals 7. How do we model this one? On the left, we need 3 x variable tiles and 8 negative unit tiles. And on the right, we need 7 positive unit tiles. How do we solve this one? The first thing we want to do is remove those 8 red unit tiles on the left side of our equation. Uh-oh, there are no red tiles on the right side. Whatever I do to the left, I have to do to the right. But this time I can't. Luckily, there's another way to remove a tile. If I add a positive yellow tile to the left side, what happens to the model? The positive yellow tile, together with a red negative tile, forms what is called a zero-sum pair, because together their sum is 0. In other words, negative 1 plus 1 equals 0. When we add a yellow tile to the left side, we must also add one to the right. Notice on the left side, the zero-sum pair cancels out, but on the right side, there are no red tiles to cancel, so the new yellow tile just joins the rest. We do this process a total of 8 times, adding 8 yellow tiles to each side of the equation until we cancel out each of the 8 red unit tiles. When every red tile has been canceled, we're left with only the 3 x variable tiles on the left side. But on the right side, we now have 15 yellow unit tiles. So we have 3x equals 15. Algebraically, we've just added 8 to each side of the equation. That matches the model. We still have 3x equals 15. In our final step, we divide our tiles into 3 equal groups to get the value of 1x. Each group has 5 unit tiles, so x equals 5. Tiles are a great way to help you visualize algebraic equations. Keep practicing, and soon you will be able to do these steps without the aid of a model.